Mercury is discharged into natural waterways from various industrial effluents such as those of manufacture of paint, paper, chlorine, and caustic soda, fertilizers, and pesticides. Among the more severe toxicological effects of mercury is neurological damage, chromosome breakage, and birth defects. So this is the one of the most serious contaminants threatening our nation's water because it is a potent neurological poison in fish, wildlife, and humans. Metalloids. Among the metalloids, arsenic is the most significant water pollutant. Although arsenic is in the same column of periodic table as phosphorus and has similar chemistry, it is more easily reduced from 5 to 3 oxidation state as 3 arsenite ASO3 3 negative is more toxic than as 5 arsenate as ASO4 3 negative, probably because it binds more readily to sulfhydryl groups and proteins. So, metalloids are the most common groundwater contaminants that present a risk to users of groundwater if concentrations exceed acceptable risk-based concentrations. Other inorganic pollutants, cyanide. Cyanide is a deadly poisonous substance that exists in water as HCN. It is a very weak acid. Cyanide ions forms stable complexes with metal ions and these complexes are relatively less toxic. The cyanide ion has a strong affinity for many metals ion forming relatively less toxic complexes, for example with iron. It forms less toxic if ECN6 for negative, whereas volatile HCN is toxic. Example, the major source of cyanides in water are discharges from some metal mining processes, organic chemical industries, iron and steel plants or manufacturers, and publicly owned wastewater treatment facilities. Ammonia. Ammonia is formed during the microbial degradation of decaying biomass and organic matter in soil and water. Nitrogenous compounds like proteins are ammonified to release ammonia into the surroundings. These organic pollutants, ammonia is one of the several forms of nitrogen that exist in aquatic environments. Hydrogen sulfide. The anaerobic decay of organic matter containing sulfur leads to the production of H2S, anaerobic reduction of sulfate in water by microorganisms is also natural source for hydrogen sulfide H2S is evolved as a gaseous from geothermal waters, waste from chemical plants, paper mills, texture mills, and tanneries may also contain H2S. It is a weak diprotic acid and is negative 2 is not present in formal natural waters. So these organic pollutants, it is an static concern that causes disagreeable taste and odor to the water. Hydrogen sulfide forms a weak acid when dissolved in water. Nitrite nitrogen. Nitrite nitrogen seldom occurs in concentrations greater than 1 mg L negative 1, even in waste treatment plant influence. Its concentration in surface and groundwaters is normally much below 0.1 mg L negative 1. Nitrite is added to some industrial processed water to inhibit corrosion. It is rarely found in drinking water at levels over 0.1 mg L negative 1. Nitrite nitrogen can cause overstimulation of growth of aquatic plants and algae. Excessive growth of this organism in turn can clog water intakes. Use is up dissolves oxygen as they decompose and block light to deeper waters, are essential for all living things, but high levels of nitrate in drinking water can be dangerous to health, especially for infants and pregnant women. Eutrophication and algal nutrients. Eutrophication is a process of providing a water body with nutrients for the life it supports. A lake starts its life as a clean body of water. Small amounts of nitrates and phosphate occur in all aquatic systems, and these are sufficient to maintain a balanced biological growth, a balance between the production of aquatic life and its destruction by bacterial decomposition. With the introduction of nutrients through land runoff and growth and the decay of aquatic life, the lake collects good amount of organic substances. Acid mine drainage. Coal mines, especially those that have been abandoned, are known to release substantial quantities of sulfuric acid and iron hydroxide into local streams. The first step in the process is the oxidation of pyrite FeS2, which is common in underground coal streams. Regulation of water quality. Governments around the world try to regulate water quality in the interest of public health and environmental protection. In the US, the legal instruments for regulation are two basic laws: the Clean Water Act, or CWA, of 1972, and Safe Drinking Water Act, or SDWA, of 1974, both of which have been amended several times. Under this act. The Environmental Protection Agency, or EPA, is required to set standards that protect from harmful effects of contaminants. Similar initiatives have been undertaken in the most of industrially advanced countries. With regard to the drinking water standards, it falls into two categories: primary standards and secondary standards. Primary standards, which specify maximum contaminants levels based on health related criteria, and secondary standards, which are unenforceable guidelines based on both static such as taste, odor, and color of drinking water, as well as non static characteristics such as corrosivity and hardness. Primary standards. Contaminants for which MCLs are established are classified as being inorganic chemicals, organic chemicals, radionuclides, or microbiological contaminants. A list of standard for inorganic chemicals have been prescribed, which included many metallic cations and anions with their permissible levels. Organic chemicals contaminants for which MCLs are being promulgated are classified conveniently using the following three groupings. The following three groupings are synthetic organic chemicals, trihalomethanes, and volatile organic chemicals, or VOCs. Synthetic organic chemicals, these are used in the manufacture of a wide variety of agricultural and industrial products. They include primarily pesticides and herbicides. Trihalomethanes, these are the products of water chlorination. They include chloroform, or CHCl3, bromodichloromethane, or CHBrCl2, dibromochloromethane, or CHBr2Cl, and bromoform, or CHBr3. Volatile organic chemical. These are synthetic chemicals that readily vaporize at room temperature. These include degreasing agents, paint thinners, glues, dyes, and some pesticides. Representative chemicals include benzene, carbon tetrachloride, 1,1,1 trichloroethane or TCA, trichloroethylene or TCA, and vinyl chloride. Secondary standards are non-enforceable. Maximum contaminant labels based on static factors such as taste, color, and odor, rather than on health effects. The limits of suggested for chloride, copper, total dissolved solids, and zinc are in large part based on taste. Excessive sulfate is undesirable because of its laxative effect. Iron and manganese are objectionable because of taste and their ability to stain laundry and fixtures.